All right, guys, this is the last section in Chapter 3. Mainly it's review, so you might pay attention. There is one little new thing, but other than that, it's all repeats. So the first question, it says, find the domain and range of this relation, then determine whether it is a function. If it's not, we need to tell why. First, the domain. You got to remember, guys, domain means your x values. And this is pretty easy if they've given us points. All we have to do is open up our squiggly line there and put in all the x values. I've got -8, -2. I've got 1. I've got another 1, so I don't have to put it in there, but if you do, that's fine. And then I've got 7. So there's the domain. Remember, your range is the y values. So let's go through and put in our y values. I've got 4, 0, -6, 4, and then I've got another -6, so I'm just going to leave it out of there. I think I put 4 in there twice too. You don't need that either. If you put it in there, though, that's just fine, so don't worry about it. Now, we need to tell if this is a function or not. And the way we tell if it's a function is we cannot have repeating x values. So this one, it is not a function. But it tells us to explain why, and it's because, I'm going to write BC for because, 1 repeats in the x's. So be careful on those problems. That should be pretty easy. I would really be upset if you missed something like that on a test. Now let's look at the next part. Now this is more from like 3-4. It says I have function notation, so it has f of x is x squared plus 4x. There's 2 x's in that. And g of x is 5 minus 3x. And wants us to find the following. So the first one says f of -3. So guys, what I'm going to do to kind of help you out is everywhere there's an x, I'm just going to write parentheses. So I replace the x with parentheses. Now all I have to do is put my x value, which is given inside those parentheses, into my new ones. So I have -3 squared plus 4 times -3. Now you need to be really careful and put it in the calculator exactly how we wrote it. Parenthesis, -3 close parenthesis squared plus 4 times open parenthesis, -3 close parenthesis. If you put that into your calculator correctly, you should get -3 for your answer. It's really 9 minus 12. Now let's move over to number 3. This is no longer using the f of x function, it's using the g of x function, and our x is -5. So I'm going to go ahead and write 5 minus 3, and I'm going to open up parentheses where there's an x value, and I'm going to plug in -5. Now you can put this in your calculator as well. You should get 20. So be careful with your arithmetic. And if you're not using a calculator, remember order of operations. Multiplication would come before that subtraction. All right, now these are also just like the other day. I have f of 1 plus g of 3. Do not add them together yet. This is not f g of 4. We have to first find f of 1, just how we found f of -3, and find g of 3, just how we found g of -5. So the first one, I have open parentheses, close parentheses squared, plus 4 times open parentheses, and I'm going to put a 1 into both. Well, 1 squared is 1, 4 times 1 is 4, so the answer I got is 5. G of 3. I have to use my g of x equation, so 5 minus 3 times parentheses, and I put in another 3, which ends up really being 5 minus 4, or I'm sorry, 5 minus 9, which is -4. Now we're going to come back and do the addition. Let me change colors here. The f of 1 is actually 5, plus the g of 3 is -4. 5 plus -4 equals 1. So just be careful, guys, and watch out when you plug stuff into your calculator. I have the same problem here, but now I've got minus instead of plus. So I'm going to have f of -2. Let's see, that's going to be something squared plus 4 times something, and I'm going to plug in my -2 into the parentheses. If you do this, you should get that it equals -4. I also need g of 4. So I have 5 minus 3, open parentheses, and I'm going to put a 4 in there. And when I do that one, I get -7. Now, order is very important here, okay? You got to be careful. I need f of negative 2, which is negative 4, and I'm going to subtract from that negative 7. And when we subtract a negative, we have a boom, boom. Negative 4 plus 7 gives me my answer of 3. Be very careful when you're doing the subtraction. Now, 6 and 7 are a little bit new, so's 8. Let's look at those real quick. Now, we still are doing kind of the same stuff we did in the last problem, but this time we're going to have to do another step. First, we have 2 times g of negative 2 plus 3 times f of 2. So, guys, the first thing we need to do is find g of negative 2. So I'm going to plug it in just like I've been doing it. Let's see, I'm going to have to use the g function, so 5 minus 3 times negative 2. Well, 5 minus 3 times negative 2 gives me 11. But I also have to look out for the 2 over here. I'm going to have to multiply that by 2 in just a second. Let's leave it how it is for the moment. Now I need to find f of 2. So that's going to be 2 squared plus 4 times 2. And that gives me 4. No, it doesn't. I'm sorry. Let's see. 2 squared is 4 plus 8 gives me 12. Now that I've found them both, I'm going to go back up to my equation. I needed 2 times my g of negative 2, which is 11, plus 3 times f of 2, which is 12. Well, 2 times 11 is 22. 3 times 12 is 36. 22 plus 36 looks like it will be 58. So there's our answer. Now the next one is kind of tricky, okay? It didn't just give us a number, it gave us another little equation. And we're going to replace every single x in the f function with 2 of x, or 2x. So I'm going to have 2x in parentheses squared plus 4 times 2x. Now, there's a little bit of a tricky thing that happens when you square something like 2x. It's really 2 squared times x squared. Well, 2 squared is 4, and x squared is just x squared. Plus, well, this is a little easier. We have 4 times 2, which is 8, and then x is attached to the end. So don't let those bother you guys. It is a little tricky, but be careful. Now we have another one that's not just a number. I have g of x minus 2. So I'm going to have 5 minus 3, but in parentheses, I'm going to have x minus 2. So that turns it into a distribution problem. So I have to distribute negative 3. So I have 5 minus 3x. Negative 3 times negative 2 is plus 6. I've got a 5 plus 6, so I get 11 minus 3x. Now those are about the trickiest problems like this you can find. Be careful, and if you have questions, you need to let me know. Let's go ahead and go to the next page. This is a pretty easy set of problems also. The first thing we have to do is list the points, and you need to count very, very carefully, because if you miss this, you miss domain and range. So let's see, the first point I got negative 3, 4. I got negative 2, negative 5. I got 0, 7. I have 2, 0. I have 4, 2. 4, negative 6. And 9, 5. And I know that's a lot of points, guys, but that should not be very hard to count those out. Now, it asks us, what's the domain? Well, remember, that's all the x values. So let's start listing them out. I have negative 3, negative 2. I have 0. I've got positive 2. I've got positive 4, but I have a second one. I don't really need to write it again. And then I have 9. Now let's look at the range, which is all the y values. I have negative 6, negative 5, 0, 2, 4, 5, and 7. So guys, doing that should be fairly easy. Be careful. Now it asks after that, is this a function? Now you could do this 2 ways. Since it gave us a graph, you could do the vertical line test. You could draw vertical lines through each point. But if you do, you notice our vertical line hits 2 points at once. So I'm going to get rid of these writings. I'm going to go down a little bit. So since it fails the vertical line test, no, this is not a function. Another way to know that is if we look at all our x values, I have 4 repeated twice. It says what would make it a function. I would need to take out either my 0.42 or my 0.4 negative 6. If I took out one of those points, then I wouldn't have 2 repeated x values, and I'd be good to go. Now we're going to have to use those points to answer the next few questions. First it says f of 2. That means I want to look at the points and find the point where x is 2 and give me the y value. Well, when x is 2 and the point 2, 0, y is 0. Then I need to look at f of negative 3. Well, when I look up there and find my x is negative 3, my y is 4. Now be careful because 7 and the next two problems are backwards. They're saying what's x when f of x equals 7. That's really saying what's x when y equals 7. So if I look back up at my points, the only place that y is 7 is when x equals 0. The same thing's happening on the next one. I need to know when is y negative 6. Well, y is negative 6 when x is 4. All right, guys, let's keep on moving. We're almost done. Now we got another domain and range question. We've done these every day since we started. These are very important, and you've got to know how to do it. I know that my notation for domain is my x's, and I know that since it's on a graph, I need to work from left to right. So I'm going to come over here, and I'm going to draw this line. This is as far left as I go. It looks like we're over 1, 2, 3, 4, 5, negative 6. And that's less than our x, but since it's a solid point, it's also equal to. Now I know x is less than my other one. I'm going to draw a vertical line through that point, and I notice it goes over 1, 2, 3, 4, 5, 6, 7, 8. But since it's an open point, it's just less than 8, okay? Let's talk about the range. I know this is y values, and this one is bottom to top. So I'm going to draw a low line here. This is as low as it goes, and it looks like that's at negative 2. I know that's less than y, and since it's an open point, that's all I have to do. And I'm going to draw a horizontal line here at the top, and it looks like I'm at 1, 2, 3, 4, 5, 6. So I'm going to say y is less than 6, but since it's a closed point, it's also equal to. Guys, some of you are still having trouble with that. I've had almost no one come in and get help, so if you need help with that, come in and talk to me. Let's go to the last page. Now these questions are a little bit wordy, guys. We're going to have to write some stuff, but they're pretty important. It says, the volume of a sphere is the product of 4/3 pi and the cube of the radius. It asks, is it a function, why or why not? Well, guys, we need to remember, if we're talking about volume and we're talking about a radius, the volume is the dependent variable. It's also the output, which means it's a y value, which means it's also in our range, okay? Then it talks about how the radius changes it, so the radius is the independent variable. Or it's our x value or our input. So they're asking us, is this a function? Well, it looks like if I were to put in any radius into that equation, if I cubed any radius, it's always going to be something different unless I put in the same radius. So this is a function. And it asks why or why not. Well, here's a little bit of writing, okay? For each possible radius measure, there is exactly one associated volume. So guys, these can be kind of tricky, but you have to think about what's happening, okay? If you're talking about a sphere like the balloon, the bigger the radius, the more volume becomes inside of it. That's why every radius I put in will give me a different y value. Now the next one says, each day the local weather station records the high temperature for the day, T, and the amount of rainfall in inches, R. Is this a function, why or why not? Well, guys, If you're going to have a function, there has to be some relation between the two. Generally, you can have hot temperatures on days it rains and days it doesn't. You could have cold temperatures on days it rains and days it doesn't. So this is not a function. It says why or why not, and I'm going to say because. There would be just what I said. There are days when it may be hot or cold and it still rains. Okay? So there is not necessarily a relationship between temperature and rain. Now let's talk about the last problem on here. It says identify the domain and range from verbal descriptions, and this can be tricky. It says you have 3 quarts of paint to paint the trim of your house. A quart of paint covers 100 square feet. The function A of Q, so A of your quarts, equals 100 times the number of quarts. Remember, the area A of Q is in square feet that Q quarts paint covers. What are the domain and range for this situation? So let's start with the domain. Domain are like our input values, if you don't remember, and it's the thing we're putting in. In our case, it's the input, and they've told us right here that it's signified by Q, which is quarts. Now, we have to think about quarts when we're thinking about domain. What's the fewest amount of quarts we could use? Well, the fewest amount would be 0. That's going to be less than or equal to our Q value, and it's going to be less than or equal to the total amount of quarts we could use. Well, we only have 3, so that's all we can use. So my domain is 0 is less than or equal to Q is less than or equal to 3. Now let's talk about the range. The range is talking about square feet, okay? The maximum and minimum amount of square feet that we can use. So I'm going to put that it's the output, and we're going to use, it looks like A for that one. Well, to know, we're going to have to plug some stuff in because I'm not sure what the outputs are yet. But I know I have an equation that A of Q equals 100 times the number of quarts. Well, I know the fewest number of quarts I can have is 0. Well, A of Q will equal 100 times 0, which is 0. So the smallest amount we can have is 0. Now that's going to be less than or equal to Y, which is less than or equal to the most we can use. In this case, it's A of 3, which is 100 times 3, which equals 300 quarts. So the most we can get is 300. Now those are pretty tricky, guys, but again, if you have questions, you need to come and talk to me, okay? I hope this goes well. Good luck.